Hello, and thank you for tuning in. In this video, you will learn a brief introduction to R and how to use R at the ASC to help students who come in for tutoring in physics and math. R is installed on all of the Windows and Macintosh computers at the ASC, and it serves the same function as a TI-8384 calculator and has some advantages over the 83 and 84 that I will show you. To start R on a Windows computer, press the hotkey, type in the letter R, look for an icon that says RStudio and click on it. On a Macintosh, on the toolbar, say hello to my sisters, their names are Judith and Grecian. On the toolbar, on a Mac, find the icon for RStudio and click on it, and a panel similar to what you see here will be displayed. There are three windows in this panel. The main window is a command window where commands can be issued to R, such as what is today's date, or an arithmetic expression, which is the real advantage of R. In the upper right-hand corner is a window displaying a history of all commands that have been issued to R, including the two that I just issued. You can tell by looking I've issued a lot of commands to R in the last couple of hours in getting ready for this video. And in the lower right is a window called Files, which shows a couple of R scripts that I have written. And it is also possible to take all of your command history from a session and save it into an R file for later use. Down here there is also a tab for help, where help on using R can be displayed, and right now you're looking at a help page on issuing commands to produce trig functions in R. More on that in a minute. I've created a little R script called hello that contains all of the commands that I'm interested in telling you about today. You can probably tell by looking that if I were to run this script, it would print a hello message. It would print the result of this arithmetic expression, and it would print the result of this very long arithmetic expression, and it would print the result of this expression. It would also create an array called Z, which I'll tell you more about later. And from this window to run this command, click on this little source button. And there's the hello message and the result of those three arithmetic expressions. And hopefully you're wondering, how were those arithmetic expressions built? So take a look at the first one. It's just some addition, subtraction, multiplication, and addition. And I just pasted it into the command window just as I would have typed it. And if I hit enter, R will take 5 times 3 plus 3 minus 4 divided by 8 and display the result. I'm going to pass on this array for just a minute and show you this much more complicated expression right here, which shows you all of the different kinds of arithmetic expressions that R supports. And what R has done is add 4 and 2 minus 4 times 12 divided by 3 minus the square root of 839 divided by the base e logarithm of 34 plus the base 10 log of 83 minus 12 to the 4th power plus Euler's constant raised to the 23rd power plus the sine of pi over 2 plus 85 mod 3. So hopefully you're asking, what are all of these expressions? I'm sure you know what some of them are, but 85% cent 3, aka 85 mod 3, is showing the remainder from the result of 85 divided by 3. This sine expression is the sine of pi over 2. R thinks in terms of radians, and in order to convert from radians to degrees, it has to be done in the expression. And this is the sine of pi over 2, which is 1. This is Euler's constant raised to the 23rd power. This is 12 to the 4th. This is the base 10 logarithm of 83. This is the base e logarithm of 34. This is the square root of 839, which can also be represented as 839 raised to the 1/2 power. And the rest of those terms are simple arithmetic of addition, subtraction, multiplication, and division. Now take a look at this last expression. You saw it at the beginning. If you've taken statistics, maybe this looks a little bit familiar. It's the margin of error for a 95% confidence level in a probability that is consistent with the central limit theorem. But that's a rather long and convoluted expression, and typing that in on your TI-84 calculator is pretty easy to make a mistake, which is why R has so many advantages. It's possible to take a very long and convoluted expression, type in the whole expression and see it and enter it. And if anything in there is wrong, and I hope you notice that 1.86 is in error, press the arrow key, the up arrow key, the previous command is displayed, and you can backspace over it and enter the correction and produce a valid result. So that's the convenient value of R and how it serves as kind of a supplement to your TI-84 calculator, with the advantage of being able to see long expressions and make corrections to them. The last feature of R that I'm going to show you is how to make an array, which is what this convoluted expression is doing. It's creating a variable called z, which is just a big long list of numbers. And if I paste that command into the command window and hit enter, a variable called z has been created, which is just a long list of numbers. And now the question is, what can I do with this? And it's possible to sum up all the values in this list. It's possible to very quickly find the minimum and the maximum value in this list, as well as the mean and the standard deviation. And if you've ever done a 5-number summary on a TI-84 calculator, you probably recognize this list, where the summary command will display the minimum, the maximum, and the mean, and the median, and the first and third quartile values for the array. There is a lot more that can be done with R. It has a lot of capabilities, but I wanted you to know that you can use it to supplement the capabilities of a TI-84 calculator. It does a lot of trigonometric and arithmetic and logarithmic functions. If you have questions or need more information, please let me know. If you would like to have a copy of this script, I can give it to you. Thank you for watching.